I would like for you to take about 5 minutes, pause the video, and see if you can factor these expressions. We did this first semester. See if you remember how to do it. How many of you paused the video? Not too many. Let's really pause the video and try this. Okay, so let's look at A here. We got 4x squared minus 9. We want to factor this. Well, the first thing that we need to do when it comes to factoring is always look for a greatest common factor. Is there a greatest common factor that goes into 4x squared and 9? Is there a number or variable that divides into both of those? No, there isn't. How many terms do we have? 2. When you have 2 terms, you can factor it if you apply the GCF or if it's a difference of perfect squares. Is this a difference of perfect squares? It is. So we can factor this. I can rewrite 4x squared as the quantity 2x squared minus, and then I can rewrite 9 as 3 squared. So what we got here is a difference of 2 perfect squares. So if you remember from first semester, here's how it factors. We would take this 2x here and write the 2x down and the 2x down. We would take the 3 here, write it down here and here. And then what we would do is put the opposite side. So we'll put plus here and minus here. If I FOIL that out, the middle terms will cancel each other out, and I end up with 4x squared minus 9. So these are the factors of 4x squared minus 9. All right, let's look at B. Again, your first step is always look for a greatest common factor. Is there a number or variable that divides into all 3 of those? No. We got 3 terms. And this is a quadratic. So this is a quadratic trinomial. So if you remember, the way I taught you how to factor quadratic trinomials is to get a leading coefficient of 1. We have a leading coefficient of 6. So we want to use the slip and slide method to factor this. We're going to take the 6 and slip it to the back. So when I slip the 6 to the back, now I have 1x squared plus 5x. And remember, when you slip it to the back, you multiply those 2 numbers together. Negative 6 times 6 will be negative 36. Now we have a quadratic trinomial that has a leading coefficient of 1. So it's easy to factor this. We can go straight to the factors. I'm going to put x and x down, because x times x is x squared. Now, I want to put 2 numbers here that multiply to be negative 36. So let's look at the factors of 36. The factors of just positive 36 are 1 and 36. What else? 2 and brain part here. That's half of 36, 18. And then we got 3 and 12, and 4 and 9. These are all the factors of 36. But we want negative 36. That means one of these is going to be negative. How do I know which one to choose? Well, the middle number, remember, tells you which one you choose. So the two factors of negative 36, they have to add to be positive 5. So that would be negative 4 to positive 9. Negative 4 times 9 is negative 36. Negative 4 plus 9 is positive 5. So the factors of this trinomial, x squared plus 5x minus 36, are x minus 4 times the quantity x plus 9. But I'm not done yet. So that's what I have written there are factors of this expression. But I wanted to factor this expression, 6x squared plus 5x minus 6. The method that we chose to use was slip and slide. So now, remember that 6 that we slipped to the back, now we gotta slide that back into our problem. So we slide the 6 into both of these. And now we're gonna reduce those fractions. So we're gonna reduce the fraction 4 over 6. That reduces down to 2/3. 9 over 6 reduces down to 3 halves. And then the last step for slip and slide, if you have to do it, is you gotta get rid of your fraction if you have a fraction. So we're gonna take this 3 and move it in front of x. Take this 2 and move it in front of x. So the factors for this expression would be the quantity 3x minus 2 times the quantity 2x plus 3. So I took this 3 and moved it in front of x. So the 3 goes there, and then that just becomes negative 2. I take that up there. Move this 2 in front of x, and then that just becomes a 3. You can check it if you want by FOIL that out. If you FOIL this out, you should get this back. 6x squared plus 5x minus 6. Alright, let's look at C. Well, C looks like B. It is. But C is easier than B. Anyone know why C is easier than B? It's easier because it already has a leading coefficient of 1. So we don't have to use slip and slide. We just do the middle step of slip and slide. So we just go straight to the factors. So what multiplies bx squared? X and x. Now I gotta find two numbers that multiply b negative 15 and add to b2. So I'm looking for factors of negative 15 that add to b2. So positive 5 and negative 2. And you're done. That's all you can do. And then let's look at D here. Well, first step we should look for a greatest common factor. Is there a greatest common factor? Is there a number or a variable that goes into both of these terms? 2x squared divides into both of these. So we can factor out the GCF. It's like doing the derivative property but backwards. Now we gotta ask ourselves, what do we take times 2x squared to get 6x cubed? 3x. Now we're gonna ask ourselves, what do we take times 2x squared to get 2x squared? Positive 1. So we pulled out the GCF, and then the last step is just check inside your parentheses, see if that can be factored any further. Can 3x plus 1 be factored any further? It cannot. So we're done. So this right here are the factors of this expression. That's stuff that we learned first semester. You still need to know it for this chapter that we're getting ready to do, working on. Alright, so I'm going to teach you how to solve a new type of an expression. So the new expression is called a sum and difference of cubes. If we look at this first expression, if we go back to our examples here, this first one, 4x squared minus 9, remember that's called a difference of perfect squares. So what we're learning today is very similar to the difference of perfect squares. But what we're doing are cubes. And it's not just difference, it's also sum. So you need to know your perfect cubes. So I gave you a list over here to the right. Here's a list of some perfect cubes that we're going to be using. It will be very helpful for you to know these. So I would write these down. 1, 8, 27, 64, 125, 216, 343, and 10, and so forth. The reason these are perfect cubes is because if you take 1 to the third power, that's 1. If you take 2, so 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. 7 to the third power is 343. And then you could do some more if you wanted, but I just get down to 10 to the third power, which is 1,000. So you could do 8 to the third power, you could do 9 to the third power. Alright, so here's the form that we're going to be using when you have a sum or difference of perfect cubes. It's always going to factor like this. It's always going to factor to be a binomial times a trinomial. So what you can do is you can remember these two forms I have written up here, but I have a silly way to remember it. It involves the word soap, okay? Here's what I mean by soap. So soap is S-O-A-P. So on this first one, we got A cubed plus B cubed. This is a sum of cubes. The S stands for the same. So right here we have a plus sign. Here we have a plus sign. It's the same sign always. And if you look down here, we have a minus sign and a minus sign. So these signs are always the same. That's what the S stands for in soap. And then the O for soap stands for opposite. So here we have a plus sign. What do we got here? A minus sign, the opposite. Down here, when we had a minus sign, what do we have here? The opposite, which is a plus sign. And then the AP in soap stands for always positive. Okay? So this last term in your trinomial is always positive. Okay? Alright, so let's just use this. So let's look at example 1 here. We got x cubed minus 8. I want to factor this. Well, what do I have? I have 2 terms. So I got to ask myself, are these 2 terms perfect cubes? They are. So I'm going to rewrite them as perfect cubes. Well, x cubed is just x to the third power. 8 is 2 to the third power. So what do we got here? We have a difference of perfect cubes. So I'm going to be using this form, but you don't really need to use that form. You can just remember the word soap. So what do? Is we write it down as a binomial, right, times a trinomial. And then we got the word soap, right? So I'm going to put an x down here, because that's my A value. My B value is 2. Okay, let's go ahead and put our signs in. The S in soap stands for the same. We have a negative sign here, so it's going to be the same sign. The O in soap stands for opposite. And the AP in soap always means always positive. Right, so now let's see how we get the trinomial parts. Well, let's look up here at this thing here. Here we got A, we had A. Here we had B, we had B. Now we got this, A squared. So A is x. So what is x squared? X squared. To get the middle term, you take your A times your B. So you're going to multiply these 2 terms together. X times 2 is 2x. And then to get the last term, you just take your B value, which was 2, and you square it. 2 squared is 4. So it's factored. If you were to multiply this out, you would end up with x cubed minus 8. Right, so let's try example 2 here. So our first step is, well, we're always going to look for a GCF. Is there something that goes in both of these terms? No. So now, I want to know, are these two terms perfect squares or perfect cubes? What are they? They're perfect cubes. 8x cubed, I can rewrite that as 2x to the third power. So the 2x is my a value. 27 is 3 to the third power. So 3 is my b value. Now I'm just going to write it out. So it's going to be a binomial times a trinomial. So I put my a value down. My a value is 2x. Put my b value down. Okay? How do we get our first term? Well, it's the same pattern every time. It's your a value squared. So I'm going to take 2x times 2x, which is 4x squared. How do I get the middle term? Well, it's a times b. So it's going to be 2x times 3. 2x times 3 is 6x. And then how do we get the last value? We just take the b value and we square it. So 3 squared is 9. And now we can use the word SOAP to fill in our signs. Right? We got a plus sign, so SOAP means the same, opposite, always positive. So there's how it factors. That's the quantity 2x plus 3 times the quantity 4x squared minus 6x plus 9. Alright, so let's do one last example here. So we got 27x cubed plus 64. So look for a GCF. Is there something that goes into both of these terms? No. So now let's see, what do we have? Do we have perfect cubes or perfect squares? We got perfect cubes. So 27x cubed can be written as 3, the quantity 3x to the third power. 64 is 4 to the third power. We got a plus sign in between. So we're going to factor it. Same pattern every time. We're going to put our a and our b. This is going to be our a squared. This term here is our a times b. And this is my b squared. Just remember this pattern. And then we can use the word SOAP, right? Same, opposite, always positive. So our a value is 3x. 3x is our a value. Our b value is 4. Okay? What is a? It's 3x. Alright, so now we got to get this value. So it's 3x squared. So it's 3x times 3x, which is 9x squared. Now we got to take 3x times 4 to get our AB value. 3x times 4 is 12x. And then last, we do just our b. Just got to square it. 4 squared is 16. And then we can assign our signs. So it's the same sign, the opposite sign, always positive. So here are the factors of this expression up here. Now you're going to try some of these on your own. I might throw in some of the old ones just to see if you were paying attention in the beginning.